Let's go ahead and take a look at how we would estimate a multiple linear regression. One of the first things we're going to want to do is perform simple linear regressions using each one of our proposed independent variables. We'd already taken a look at machine hours and also indirect labor hours, or rather direct labor hours, and decided direct labor hours wasn't a good predictor. But let's go ahead and do our scatter graph one more time using machine hours. So highlight machine hours, our indirect manufacturing labor cost. And we're going to go up to Insert, Scatter Graph, and let's just put it right over there. Let's shrink it just a little bit, and we're going to right-click, add a trend line. We want to display the equation and the R squared on our chart. Let's put them right there, and there was our 52% explanatory power. And we've also proposed or thought about considering the number of production batches. Perhaps that's we think that it would also drive our indirect labor manufacturing costs. So let's do a scatter graph for it. So again, highlight our data, go up to Insert, Scatter Graph. And let's just shrink that down just a little bit, bring it over, and once we've got that in place, right-click, add your trend line, and we'll display our equation and our square on our chart. And we can see that our number of production batches seems to have some explanatory power. It explains about 47% of the variability in our indirect manufacturing labor cost. So both of these appear to be independent variables that have some explanatory power in explaining our overall indirect labor manufacturing cost. So let's go ahead then and run a multiple linear regression model using both of these variables. To do that, again, we're going to go up to Data, Data Analysis, Regression, our independent variables. And again, this time notice I'm including my label up top for my dependent variable, my independent variable. Those are my X variables. I'm going to highlight my machine hours, production batches, all the way down. Okay, and my output range, sure, we'll put it down here in cell B22. So let's hit OK. And now let's go ahead and take a look at our regression output. In looking at our regression output, we can see our equation takes the form our y coefficient, or our slope-intercept is $42.57. The slope coefficient for our machine hours, or x1, is $7.60 per machine hour. And we expect to incur a cost of $37.77 per production batch. In terms of overall explanatory power of our model, not surprising, both of these variables had some explanatory power on their own, and we add them together. We seem to have a pretty decent model. We're explaining roughly 72% of the variation in our overall manufacturing cost, or indirect labor manufacturing cost, using these two independent variables. We can also see that if we look at our F statistic when we have a multiple linear regression, and we're very big, a good solid F statistic. In fact, we're significant at the 0.003% level. So if we had had a significance level of 1%, we would have accepted this at the 1% level. And so it's a very solid model. If we look at the T statistics for each one of our individual independent variables, we can see that the T statistic for our machine hours of 2.75 is a little bit higher than the 2.4 for production batches. So it seems to be a little bit more solid in terms of predicting power, and that's not surprising because we saw it had the higher R square up top. And yet both of them, when they're modeled together, they both remain significant at fairly high levels. We would have accepted the hypothesis that both of these coefficients are different than 0 at the 5% level. In fact, we have a 2% probability for our machine hours and a 3.5% for number of production batches. Again, one of the reasons we're putting together our cost estimates is we want to predict our cost. Let's say we want to predict our overall indirect manufacturing labor cost at running of, say, 80 machine hours and producing 14 batches. And let's check to make sure that is within our relevant range. 80 machine hours seems to be solidly within our relevant range for machine hours, and our production batches, 14, seems to be within our relevant range for production batches. So our predicted cost then, we'll use our cost equation. The fixed component is $42 plus 80 machine hours times our slope coefficient for machine hours of $7.60 plus 14 batches times our number of production batches. And we would guesstimate an overall cost for indirect labor manufacturing hours of $1,179 if we were going to run our machines for 80 hours and produce 14 batches.